So our senior project is a recirculating solar hot water heater system. We use a solar collector panel which uses copper tubing and natural convection to get recirculation of the hot water. Over here we have our reservoir tank, which will provide the pressure head to drive the system. And then we have a tank over here which simulates a pre-existing hot water heater in a home. And also we have a pump system to recirculate the hot water once the temperature between the two tanks is great enough to replace it. The advantages of the system are that it replaces the need for heating hot water with natural gas, where you use solar energy to heat the water, and you actually get a cost savings of $10 per month. So in about 3 years, the entire system will be paid for itself, and you can, have hot water consistently and very cheaply.
So this is a convertible tandem bike system. Basically what it allows you to do is it allows you to take two regular individual bikes and convert them into a tandem system. You don't damage either one of the bikes. They function perfectly as individual bikes as you take the frame extension off. And as you can see, it poses itself. It has 3 wheels. We fabricated the giant orange thing. And basically, this is what we're calling our frame extension. It extends the frame of the front bike. It can go on either bike. We were planning to have 2 of these so that one could be on this bike as well, so that we can store the 4th tire. All the parts are stored on the bikes, and it's just one whole self-inclusive tandem system.
So my name is Richard Tachko, and my senior project was developing a website for the faculty on University of Pacific that allows them to vote in their faculty elections. So the whole purpose of this website is to replace the old system. How it worked previously was the old system would have PDF ballots that were sent to all the faculty members who were voting via email. They would have to then mark their ballots and then return them via email back to one person who would have to manually count all of those votes. So this website automates nearly the entire process of that old system. So how it works is basically you are a user, you log in through Inside Pacific, and then you click on a link and are redirected back to this website, and then from this website you can select the election you want to vote for, you can vote in that election, and that's basically it. So the entire process for the end user is simplified, and that's one of the primary aspects of this website. The second aspect, again though this probably is the primary, is the security focus of the website. With any election, you want to make sure that it's secure, you want to prevent people from voting multiple times for voter fraud, right? And those are some pretty hot topics that are associated with voting in our government and all that stuff. And so there's heavy emphasis placed on security within the website. So people are only allowed to vote once, they are not allowed to vote for people they're not allowed to vote in elections they should not be voting for. And so there's a whole lot of code and logic dedicated to ensuring the utmost security of the website.
I'm Elizabeth, and our group, we did a Greek theater. The Greek theater was made of concrete retaining walls, and we had a drainage system that included a bioswale to make it more sustainable. And the reason we chose a Greek theater was because we wanted to add an extra outdoor venue that could be used for public events and more intimate events like weddings, and then we could have tiger nights too.
So is this a 3D model that you made?
Yeah, we used this 3D model to help us figure out how it would look, since aesthetics was important, and also to check our work. And the program we used was Google SketchUp, which offered us a lot of isometric views and textures to make sure that it looked the way we pictured it in our heads.
So the brains are inside this box. Basically, when you hit the auto cycle button on the front of this box, it activates the motor here, driving this drive shaft. The drive shaft causes the gears on the top and bottom of the board to crawl along this track. And as it crawls along this track, the brackets wrap around and basically drag the eraser across the front of the board. And then these little whiskers that you see here are a crude version of positional switches so that the controller knows where the motor is. And that's how the program is controlled.
Very nice.
So I did my senior project with my work project at Lawrence Livermore, and what we wanted to do is create a mobile web application for field data collection. And the reason that we wanted to go the mobile web route is because we had applications in the past that were coded for the Palm Pilot, and those things are equivalent to doorstops now, so it doesn't work out too well. And so we wanted to be able to target a number of devices and be able to reuse our code through the ages. And so that's why we came up with this route. The only caveat being for our application is that it had to work both on and offline. And so what we had to do is make a mobile web app that really functions without the internet too, which was kind of a difficult thing to do. But with that framework built out, it's actually really easy to stand up a nice application that has a good GUI and is very user-friendly. And that's thanks in part to the jQuery mobile spec. They make making a nice user interface very simple. It looks like a native web application or a native application to a system, iOS or otherwise. And some of the future work that we hope to implement is with overlaying some of our map data from our GIS servers onto a Google Earth map, so that workers can more efficiently collect data from different sites and plan out their routes ahead of time. And that's my application.
So what do you have on the?
So on here, I have this is basically what the text in the field would see. This is the splash screen itself, and then they can go. And right now it's actually running offline. Even though I have internet connection, I'm not actually connected to any of our servers.
Okay.
So all of this data has been cached. It's stored on the device itself. And what somebody collecting data can do is just come out here, go to the particular area that they're working in, pick a well that they haven't completed yet, add whatever information that they need to, add a depth of water, a note, save their changes, and come back out.
So it's a motion sensing glove. It's got 3 degrees of freedom, space, and 3 degrees of rotation, and 5 finger sensing, 2 pairs of them, and you can manipulate objects in a virtual environment. The possibilities are limitless. And show the other things you want to use.
Hello, my name is Tyler, this is Brendan Hill, together we're Team Wizard. Project Alpha is a co-current laminar flow device. Essentially what we're trying to achieve is we're trying to achieve 2 cohesive streams of fluid, flowed at the same rate, the same velocities, in a concentric pattern, meaning that we have one stream completely enveloped by another stream of fluid. What we hope to do with this device is use it to spin spider silk. Currently, spinning spider silk involves volatile solvents that get trapped in the spider silk fiber, and these pockets of solvent weaken the overall fiber strength. So what we're hoping to do is, by using this device, we're hoping to achieve diffusion of the solvent out of the fiber as the fiber forms, so that we have a more cohesive and solid fiber, and ultimately result in a stronger fiber. But essentially what we're able to do is we were able to cut a notch into this fiber, this tube itself, and within that tiny notch, which is right here, we threaded this fiber, or this tube, into the larger tube out here. So they're both on the scale of hairs. And so as you can see, once we formed the seal, once we formed the junction, we sealed with epoxy, and then we sealed each tube to its own needle. Wow. And so each of these needles is attached to one of these syringes, and then we're able to flow 2 liquids together in a concentric pattern. So that means one inside and one on the outside.
So we had to design a small-scale wind power generation system to power a sensor network for Dr. Basha. We we went with a vertical axis wind turbine with a full wave rectifier inside the base that goes into a project box at the bottom that contains all of our electronics, including a microcontroller that transmits and senses all of the data in form of power generation from the wind turbine and battery conditions. That transmits out to a computer onto a GUI that then displays on a graphical user interface.
We're able to store the wind energy from the turbine in a lithium polymer battery, which powers all of our internal circuitry and is all consolidated down there in that box.
So in terms of the software side, we basically use an Arduino to basically just read the input voltage, current, and the battery voltage.
So where would you put one of these? Anywhere?
On top of the building.
In a field, under a bridge. The base is designed to be modular and be able to be mounted anywhere needed.
I love engineering.
I love engineering!
I love engineering and computer science.